Today, we will look at object-oriented programming. We will write TinySelf, which is a small programming language inspired by the self-programming system. Now, not many people know about Self. Self was created in the 1980s, and it was an attempt to create a very pure, minimal object-oriented programming environment, which is why it's a great fit for our course. So what does object-oriented actually mean? Today, most people who talk about object orientation expect that it means 4 different things. An object-oriented language needs to have dynamic lookup. This means that if you have an object and you call a method or you send it a message, the object can determine how to respond. So this is something that's not decided by the compiler, but at runtime, different objects can respond in different ways. Abstraction means that some state in the object can be hidden from the user. So typically this could be private fields and similar things. Then an object-oriented language needs to have a subtyping mechanism, which means that if you have some code that expects some structure, some objects of some structure, any other object that has the same structure that's compatible with the one that is expected can be used in place. This can be again implemented in various ways. In dynamically typed languages, you just need objects to have the right methods that will be invoked. In statically typed languages, this may mean that you need to have you're expecting an interface, you take any object that implements the interface. And then object-oriented languages need support inheritance, which means that you can take an existing object or a class and use it to define a new object or a class that adds some more functionality. So all of these things are implemented in different ways in different programming languages. In Java and C#, subtyping is done through static type checking. Inheritance is really you're inheriting from a single class. But for example, in Self, inheritance is done by adding a prototype to your objects. So there's many different ways to have an object-oriented system, and we will look at Self, which makes one particular set of choices. First, let me say a few words about the history of object-oriented programming. The first language that's generally called object-oriented was Simula, which was created at the end of 1960s, and it was a language built specifically, as the name suggests, to create scientific simulations. So you could define agents, and then the agents could have some behavior, they could have some state, and then the system was composed of agents. And you can already see how this resembles objects. And as the Simula language developed, they slowly started calling these things classes and objects, and not just agents. So the ideas emerged from scientific simulation, and then in the 1970s, the programming language Smalltalk took these ideas and embedded them in a very different environment. Smalltalk was built for some of the first computers with graphical user interfaces. So the Smalltalk language was really a programming system with a rich environment where you could view all your objects and classes and modify them. And the idea of Smalltalk was very much, this is going to be the unified interface for working with a computer. So objects became quite a different thing, and also the language then was dynamically typed, had this idea that objects communicate by sending messages, which is the rough equivalent to method calls. And Smalltalk was dynamically typed because it expected that it will operate in a very big world where there's lots of other objects to talk to. In the 1980s, the ideas of object orientation got a bit more engineering perspective. And in the 1980s, C++ sort of took the very low-level language C and added object-oriented features to it, focusing on, as the author said, serious programmers. So they were clearly making a stance against Smalltalk, which was a very alternative idea. And other languages like IFL tried to build a solid engineering discipline around object orientation. The book cover of IFL and IFL book and the name of the language was chosen because they admired the Eiffel Tower, which was built according to the given schedule and on budget. So they were hoping that object-oriented programming can do the same for software engineering. In the 80s, this is also when Self was created, and Self was a continuation of some of the ideas from Smalltalk, but they thought that Smalltalk was too complicated with objects and classes being different things, and they tried to come up with a different way of doing object orientation based on just objects that can have prototypes, which are other objects, and that's a mechanism of avoiding classes. And 1990s and 2000s gave us the Java programming language and C#, which extracted the class-based object-oriented programming, somewhat more of the C++ style. So there's a lot of focus on engineering and structuring code, and not much on things like reflection and uniformity, which was things that mattered to Smalltalk and Self. Prototypes that are known from Self then made it into JavaScript, and it is worth noting that many of the implementation techniques from the Self language were actually behind the V8 JavaScript engine. So why are we looking at TinySelf? It is a nice, pure, small object-oriented programming language. So Self is very, very simple and uniform, and in Self, it's really the case that everything is an object. And it's simpler than Smalltalk, and it's also more illustrative than looking at how to implement something like C# or Java. It also shows you some of the missed opportunities for working with objects, where in Java, classes are really just a mechanism for structuring code. But in Self, as we will see, objects exist for representing state. You can use them for representing code, but they're also used during the execution. So the same thing happens pretty much everywhere. Objects also in Self and Smalltalk have this support for introspection and debugging, which means that you can look at object and see what method it has, and through the same mechanism of object-oriented programming. In Self and Smalltalk, this means that it's extremely easy to write things like debuggers, which will look at the current state of the system, analyze it, give you some useful information. And Self, although we will not really look at any of the details here, has some nice ideas for integrating objects and graphical interfaces. So that's also an idea that's worth looking at. The user interface aspect, that's something that evolved in Self over time, but later versions of Self came with the morphic user interface framework, and the idea of the basic idea of the framework is that you can have objects on the screen, and the thing that you see on the screen is the objects themselves. So things on the screen are objects, and you can take it to the extreme, although in Self you can hide some objects, but really you can say, well, everything you have is somewhere on the screen. And there's different ways of looking at the objects. One way is some sort of default view where you see the different slots in the objects and you can edit the values there, or you can have objects that define their own look and then they become some kind of shapes. But again, you can manipulate these objects because they're just objects. So this leads to a kind of visual programming where you see your objects on the screen and you can create new objects and you can link them together, and that's how you construct your programs. Before we look at programming in Self, I want to show you another demo that's illustrating some of the ideas that we will be looking at in TinySelf, but using a slightly bigger programming system that I wrote earlier, which is trying to do a small version of Smalltalk. So this has more capabilities, but it's still a tiny system, and it has a nice aspect, which is that you can see it on the screen. It's got a nice visual environment. So what I have here is a little programming system with class-based object-oriented programming model running in the browser. And I have one object here that I opened, and the object is some object with a bunch of demos. So what I can do here is I can, for example, open this platform value, and this is a reference to some global platform object that gives you access to all sorts of things that you might need. So it has, for example, the print method for printing, and there's some functions for working with classes. You can create a new class and so on. So this is a object of a class platform, but the class itself, that's also an object, and I can open that, and now I see an object. The class of this object is a class, and inside this object I can see its name, so this is platform. I can get its methods, and the methods is some sort of lookup table where I can see, for example, print, and print is a native method which is implemented by running, in this case, some JavaScript. So another thing I can show you here is I can open this workspace object, and this object defines its own visual rendering. So it replaces the default view with some sort of interactive editor where I can enter some code. And now this is really minimal, so I have a very primitive editor for defining code, but I can say I want to create code that's a message send, and I'm going to send the message to a local variable, which is going to be called workspace. And the message is going to be print. So we're going to print something, and I will add an argument. And the argument is going to be a string called hello world. And now I can click this link here to run the code, and you can see the output in this workspace now contains hello world. I said earlier that one of the key ideas in Self and Smalltalk is that the environment should be self-sustainable. So through reflection, through the fact that you can look at all the objects and view them and edit them, you're able to modify the system. And so one interesting thing here is that I have the workspace visualizer here, and that's a component that's responsible for rendering this user interface. And this contains some code, and now my visualizer is rendering. Well, what you can see here is a sort of visual representation of the code that's responsible for rendering this workspace box. And So we can see it creates a div, and inside the div there's a heading, workspace, subheading, code. Then there's a call to visualize the code that's inside the workspace, and then there's the output. But this is just creating an HTML, so I can, for example, say add a style, background, and I can set this to some different color. If I do this, once I modify the object, the whole thing re-renders, and immediately you can see that my workspace has turned pink because I've changed the code I've changed the objects that represent the code that's responsible for rendering the workspace. And in the same way, I can open this class visualizer, which is the component that provides this default rendering of these things. And for example, I can change this string class. I'm going to translate this to check. So here I will say třída. That's the check for class. And now suddenly, at least the heading of my visualizer is in check. So this is something that's TinySelf that we will be working with is going in this direction of creating a thing where everything is object, everything you can view, edit, and modify. And here I have a system where you can, through a graphical interface, edit code, modify the code for the system itself, modify its rendering, and it's all based on objects and classes. And the whole thing is actually relatively small. The implementation, there's some 70 lines of code that are the UI side of things, where we take objects that represent HTML that are created by the system itself, and this is really the bit that creates the DOM elements and interfaces with the browser. So that's maybe 70 lines of code. And then the implementation of the system itself is some 1,000 lines of code, 900. So in less than 1,000 code, we were able to create a system that you can use to modify itself. And even then, out of these 900 lines, vast majority of it is using this little pretty ugly F# domain-specific language that I created for defining the code in the self objects. So all of this, maybe half of the implementation, is just defining things that exist in the self world, in the self image. So this is not the kind of core implementation of the Smalltalk here, but it's just code that exists when this particular system starts. So what are we going to implement for TinySelf? We're going to not do classes. We're going to work with prototype-based implementation. And in Self, and we're going to do that as well, we will work with multiple inheritance. So you can have an object that has multiple prototypes, and we have to do the clever lookup and message sending logic that Self uses. So this shows some of the basic structures of the Self programming language. We will also use self-inspired implementation of method invocation, where when you're invoking a method, you need to provide it with an activation record, and the activation record gives you access to the method arguments, the instance of the object that's being called, and as you might now expect, activation records are also just objects. So we'll see how all these things work when you work with just objects. We will then add some simple representation of expressions of code, and we'll have a sort of built-in F-sharp interpreter for this. So here we're pushing a little bit more of the implementation from the self system itself into F-sharp, but that's a trade-off worth making because it will make our implementation a little bit easier.